Good morning, everybody. My name is Vinny Alvino, and I am the product manager of traffic safety here at Laser Technology. Today we have a great webinar planned for you. We're going to be going over the TruPoint 300 system. We're going to be talking about measuring the damage profile of a vehicle for crush. Many of you out there are probably going to be familiar with it, but many of you would be new to this. And this is just going to be packed full of information. So we're glad you could join us today. We'll get started. A little bit about Laser Tech. Laser Tech's been doing what Laser Tech does for about 35 years now. LiDAR is at the heart of everything we do sell. You could see from that screen you could see from the screen in front of you to the right some of the equipment that we sell. In the upper right-hand corner is our latest speed measurement device that will also allow you to get not only the speed and range, but images and images and video of the infraction. And then to the left of that is a piece of equipment that is used in a crash scene investigation. And today we're going to talk about one of the items used for that, the TruPoint 300, but we're going to look at it a little differently. We're going to look at it for crush. The bottom right is a TruSpeed SXB. That's one of our latest units as well. That has, it's a very stealth unit. Not only does it do speed and range, but it could also do mapping. So if you're looking for a versatile unit, that would be it. And then in the bottom left is a little bit of our history. You could see there that's an astronaut docking up to the space state, from the shuttle to on the shuttle. Docking their module. And so what they had asked LTI to do was to kind of make a little deviation of the unit they were selling at the time for speed to use it in that capacity. So that particular unit became pretty standard equipment on the space shuttle missions for years. Rich, who's going to be joining us in a minute, the first unit he actually bought was about that big back then, and now you can see over in the right-hand side, the bottom right, how small these have become. Again, I am Vinny Alvino. I've been with LTI now for about 10 years as the product manager for traffic safety. My background is in product management. I did that at Jepson. I also did a little bit of it at Lockheed Martin before becoming a lean facilitator. And then joining us is Rich Maxwell. He's going to be going over how to use the TruPoint 300 in the environment for crush analysis. He was with Colts Neck, New Jersey PD for 27 years, retired as a sergeant from there. And in Monmouth County, where that was located, he was also the countywide fatal crash investigation team lead there. So he's got so many years doing this type work. He also trained forensics at the Monmouth County Police Academy. He's worked at Rutgers, working on curriculum there for speed enforcement and for crash reconstruction type work, as well as Keene University there in New Jersey, right around Elizabeth. So again, he has just got years of experience, 30, 35 years doing this type work, and you're going to find this webinar to be very exciting today, very informative. Again, we're going to be looking at the TruPoint 300, which is basically a very compact total station. And he'll talk about a few of the uses for it, but today we're going to be looking at it in light of profiling a damaged vehicle. The kit that we sell, when we do sell this unit, it comes with the unit itself, the TruPoint 300, as well as a tablet and the software for collecting the points. It comes with a tripod and all the bracketry, a laser aim assist piece of equipment there as well on top of the tripod. And it all fits neatly in a Pelican hard case. It comes in such a small package that actual case could fit in an overhead bin of a airplane if you were traveling with it, or taking it somewhere else in the state, or whatever you might be doing. So with that said, everything is included in the kit that you would purchase, and it being a total station, it's extremely reasonably priced. It is a class 2 laser, so we're going to let you know up front, if you're using this, do not point it at anyone. So you do need to take caution. The rest of our equipment, as you're aware, if you're familiar with laser technology at all, we do manufacture Class 1 products, but this happens to be a Class 2 laser. So you just need to be a little bit careful with it. So with that said, I'm going to turn this over to Rich now. He's going to start the presentation today. And Rich, take it away.
Morning, Vinny. How you doing today?
Good, good, good. Thanks for joining us.
No problem. I'm just going to start talking basically about, this is going to be detailed, not real detailed as far as how to use the device, but basically how to use it to map and measure a profile of a damaged vehicle. And you can use these profiles more than just for doing crush measurements. You can determine maximum engagement on the vehicle with it. You could also take, if you're going to put the vehicles together on your diagram at maximum engagement and so forth, you could actually match the two vehicles up or the vehicle up with a pole or so forth, because you'll have the exact profile damage of the vehicle that you could use like that. It also helps you to determine principal direction of force when you look at the overall vehicle. And then when you do your scale diagrams in the crash sequence, it'll work like that. So I guess, Vinny, you go to the next slide.
Yep.
Typically, we're those of us that have done crush measurements, and a lot of us tend to steer away from it because it's a detailed, long activity that's done by hand most of the time. And you utilize the tape measures, excuse me, levels to make sure you're on there. They also make it the jigs where you can set up a profile box around the vehicle to measure from, or those, a lot of people have seen or may have used the setups with the rods where you measure the depth of the rods going in. And then you measure this comparison. Either you have to find an exemplary vehicle to measure off of, and then do the difference between the crush measurements, do some calculations that come up with the actual measurements as far as how deep the penetration is into the vehicle. And then depending how you calculate your speed, which we're not going to get into that part of it today, but you would either enter it into your program, computer program, or do your calculations longhand. And the question has always come up here. A lot of people don't tend to go towards crush because, it's not actually that detailed, that precision, because you're going to be off by an inch or two here, and you're not really sure the accuracy of your measurements. You do it by hand. So if we go to the next slide.
And Rich, at this, and you'll be talking about too how the accuracy of the TruPoint 300 is going to just aid in that last bullet point here. So it doesn't take the accuracy into question at that. I mean, it is accurate.
Sure. So the TruPoint 300 in combination with your CAD program is where the accuracy comes in for this.
Okay.
So now, if we look at the aspect of trying to utilize the TruPoint 300 to do this, one of the biggest things that brought my attention to it when LTI came out with the device and they introduced it to those of us that do the work for them, it really kept emphasizing the accuracy is plus or minus 1 millimeter. And even though this device wasn't intended when they designed it, was not thought about doing crush, it was more for doing inside crime scenes and smaller crime scenes or crash scenes and so forth. You could do with that. The accuracy comes into play here now that we can get very precise measurements doing any type of scaling with this, or any type of scene you're going to measure with it. So you could set it up like a total station would be set up. You work from one spot. You can measure right directly to the vehicle. If you want to do the far sides, if you don't want to move around the vehicle and stay in one position, you need to use a prism pole with a non-reflectorless, a reflectorless pole, because of the laser, you can't use a prism itself for a high reflectivity surface because you could damage the laser by coming back at it. And the big difference is here, it's a red point. Where you put that red dot is where it's going to measure to. And it makes the measuring so much quicker and easier to do it. The number of points, as we know, when we do measuring with total stations or LTI lasers, it's endless. You can keep shooting as many as you want to. One of the neat features, for those of you who aren't familiar with LTI's equipment, that in recent years, because everything's wireless now, you're using a tablet to do your data collection. There's no cables hooked up to it. You can actually fire the laser from the tablet too. You don't have to push a button on the laser to fire it. But they've added a feature where you could take a picture with the tablet while you're in the program for Quick Map 3D. So you could actually take and shoot a point and then go up to that point and take a picture of it, and it attaches that file number to the photograph in your memory system, so that way you know exactly where that picture goes to. So here again, you could also use this to take a couple of quick pictures to set up show up where you're measuring to, or if you're a question about what that point is, both at when you're doing the scene of a vehicle crash, you could also do it that way too, in addition to the profile we're going to talk about today. And the really important thing about this that really kind of caught me when I started playing around with them a while ago, it's so quick. For example, the car that we are using today in the webinar, I just, because one of the things that was a side note is I wanted to find a vehicle that had some decent damage to it to utilize for this webinar. And one of the problems with what's been going on with the COVID-19 is traffic has been down, so there's not a lot of crashed vehicles to find out there that utilizes. So I did locate one a couple of weeks ago at one of my local tow yards, and it took me less than an hour to set the equipment up, take my time measuring, take a bunch of pictures for it. In addition to using the laser, I used my camera to take pictures as I was set up for this. And I was done in less than an hour doing the whole profile of the vehicle and doing a second profile just along the front of the vehicle, just to try that aspect out of it too. So the time you're going to be doing with this is very limited compared to setting up the jigs or setting up your tapes and so forth when you did it by hand.
So, Rich, you were saying this was in about an hour or less for this vehicle that you're doing for this. And you were saying when we were talking the other day, this would have taken how long if you had gone through the normal procedure?
If I was trying to do it by myself, first of all, because I did this all by myself, a one-person operation when I did the car that we're using today, it would have taken me at least a couple of hours, more than that by myself. And if I had to have somebody to help me, it still would have taken a couple hours to do all the measurements and so forth.
Okay. All right. So it's a real time-saving piece as well. As well as the accuracy. Okay.
Now, there's two different schools of thought when you're doing the measuring of the profile of the vehicle using the laser setup. One, would you just leave the station in one position and measure the whole vehicle from there, or just measure the damaged side of the vehicle if that's what you're concerned about? Or you could, if you wanted to get detail on more than one side, you could traverse a station, just like you would traverse any total station. You could do around all four sides of the vehicle. So there's two different schools of thought of how to measure the profile of the vehicle. What we did today, I did it one position. I measured everything in one position and used a prism pole to do the back corners and so forth on it. Then once you take and you do your collection, you download your points into the CAD program, you draw the outline of your damage profile to scale, because your points are going to be to scale. And then working with the layers in your CAD program, you would overlay your damage profile over top of the vehicle itself out of library, or if you obtain a vehicle outside the library from somewhere else. And if you could also, if you wanted to find the exact same vehicle, you could use the TruPoint 300 to do a undamaged profile of it. It would take you nowhere near as long, because you're just doing a couple of points compared to the detailed points you do where the crush is. And then once you draw these and you compare the two and overlay the two of them, you would then measure your crush using your CAD program. And we know the CAD programs are very accurate as far as their detailed measurements, and you'll see that later on in the program we talk about today. And now you then take your calculations, your numbers out of the CAD program, you then use that in your calculations to do your speed determinations.
So this particular, with the CAD program, back to the kit that we sell. So the CAD program we sell Faro, and you can use it with anyone, but we sell Faro 2D and 3D. And you were indicating when we were talking through this that you're using 2D.
Yes. Correct? So we only do this in 2D because we're looking for that flat diagram profile so that we can work with it overlaying over top of each other. Because, and as we talk about it, we go through the program today, you're going to look for the deepest penetration. That's what you're looking for, and you want that plane that you're going to be measuring on. So you do everything in 2D, and you don't have to worry about 3D measurements with this, because that's what you're just working with, that one slice of the vehicle, if you want to look at it that way.
Okay.
This is our exemplar vehicle, or our crash vehicle we're going to use today. Even though it is a 1998 Volvo, it was involved in a crash in May, so it's not like it's been laying around in a junkyard for a while. But it's a station wagon, and one of the unique things about this, when you start thinking about it, everybody's technology nowadays, we use event data recorders to get data information out of it. Well, here we have an older vehicle that was involved in a recent crash, and you might want to figure out at the speed and so forth. There's no pre-impact conditions to come up with. There's no speed, there's no skid marks and so forth. And if you go to the next slide, you can see we start looking at where the damage of the vehicles. It's one of your typical written by the book square hit into a pole. And there is no other way to figure out. You might have to revert to crush to come up with a speed for this type of a damage in a vehicle. So we're looking at, you can see the nice square centered hit. And as I said, this is a recent hit. This happened in May, this crash. Next slide. This is an example how you would know. It's called radial of angle. This is the portion of the Quick Map 3D program that does the data collection. You set your 2.300 up on a station, and then you would do your measurements profiles of the damaged side of the vehicle. Now, if you just want to do the damaged side of the vehicle and that's all you wanted to do, that's fine. You can do it right there. You're done. You shoot as many points as you want to. You could start at the one end of the vehicle, work the way down to the opposite end, and you could do detailed. The points can be as close together as you want to be when you're measuring, or you could be as far apart as you want to be. You're the one's going to be setting about that. If you wanted to measure the far side, as I said earlier, you're going to use a prism pole with a non-reflector prism, if you want to call it that, on top of it. And if you wanted to take in traverse around, you would move that station to another point, either on the other side of the vehicle, or if you want to do all four parts of the vehicle, the front and back, and also. And as Vinny emphasized before, and I talked about, we do all our measurements in 2D. We don't have to worry about the prism height. We don't have to worry about the target height and so forth like that, or the station height, because we're doing in 2D measurements.
Okay.
So if I'm going to measure, just to move it from, do all my measurements from one position with one station setup. And as you can see with the vehicle I did for this program, it was tucked in with some other cars, so I couldn't get all the way around it with the prism, with the station. So you need some free space setup. Probably about 6 feet's a good recommendation. You don't want to be too far away. You don't want to be right on top of it too. So 6 foot's a kind of a good space area to be there, because you can set your station up on the one side. And if you do want to measure the other side, you don't have to worry about space. You could use a prism pole to do that. So yeah, free space areas you need to work in and set up your equipment into. Okay, next slide. Here's where the actual photograph of what I set up. You can see to the right, the damaged vehicle. It was tucked in with some other cars that were in the tow yard. And then the station is set up to the left. It's a typical camera tripod is the base. It's nothing really heavy duty or elaborate to deal with as far as taking up space when you store it. And on top of it, you can see the TruPoint 300 setup with the angle assist. And I'm about, you can see maybe about 7-8 feet away from it, somewhere around there, 10 feet away from it when I set it up.
Oh.
Okay, next slide.
Okay.
So now what you want to do is you want to take the vehicle in question you're going to be measuring. Now this diagram here, we have a damaged side on the driver's side of the vehicle. You want to look for the deepest point of intrusion. That's what you want to do for your crush measurements. And you want to set up a 2D plane that you measure along so that you stay consistent with that same plane as you measure, just as you would if you're doing it by hand with either a jig or the rods going into it. You want to measure that whole plane all going along there. So you want to measure that deepest intrusion by hand to kind of, or you can visualize it where you're going to measure from, but then you'll measure the height of that from the ground, so you can set up a guide to follow. You can use painter's tape, which won't damage the vehicle because it peels off easy like that. String, chalk, anything like that to follow along that plane. So when you do the measuring, you're going to follow that dotted line basically when you're measuring that side of the vehicle, so you can stay on that same plane going along there. Okay, next slide. So here's an overhead view of the damage. You can see where it goes in. Now you can see the hood is not as crushed far back as the bumper. So my concern is I want to measure where the bumper is. I don't care about the hood's damage, even though it has that contact damage on it. I want to get into that deepest intrusion where the bumper is pushed, that the bumper mounting underneath. So I measured the height from the ground. It's about 19.5 inches, between 19, 20 inches. So I'm going to set that as my plane from the ground all the way around. So when I put the tape or whatever I'm going to use to set up as a guide, I want to measure that and keep it at the same height all the way along the front of the vehicle where I'm going to do the damage profile. Okay, next slide. And you can see I use the blue painter's tape as my guide. I set up so this way I can just follow along that tape and stay at that same plane, so I get the same consistent measurements at the same level. Okay. Now I set up the tripod with the angle assist on top of the tripod. They both have their own levels, so I'm going to level these devices first to make sure that the tripod is at the level, because I'm working from a level base then. And you just do that by adjusting your tripod legs. It's very simple, like we do with the total stations and the other mapping systems we use with LTI.
Hey, Rich, a question. You keep bringing up total station, and this is one basically, a very compact and accurate one. The actual total station, advantage, disadvantage to it to use in a situation like this? Just is it overkill? Is it? I
Well,
mean, what is the advantage or disadvantage of what people would typically call a total station?
and that's true. I'm referring to this as a total station
Right.
because that's what you guys can kind of market it as a small total station.
That's right.
I know that this is not an. I'm not coming up. I didn't invent this process to do this because there are, and maybe some of even our attendees have done it, utilizing a total station to profile a vehicle. But the difference, the big difference that between the LTI equipment and total stations is the speed and accurate ease of using it. You set
Okay.
it up much quicker. You're done much quicker. Your shooting points. I'll go back to years ago with the old when we started with the angle encoders, the impulse and so forth. I was teaching a class, and one of the other instructors with me had a total station, and part of the class we were teaching was a basic crash investigation, and the students had to go out to measure a crash scene for their project. And so I went out and I wanted to measure real quick with the LTI impulse setup with the angle encoder, just to get a basic reference to make sure they were measuring it correctly by hand. And so my fellow instructor, so I got my total station. I was set up and measuring, and halfway through, while he's still setting up the total station. Now, granted, it was years ago, and their technologies come along a little bit different as things have worked with it. But the biggest thing I still find is the simplicity of the operation on it, and the fact that you can set it up and you're into the measurements very quickly in comparison to setting up a total station.
Okay. I was just wondering what the. All
And
right.
and now we've fallen into the aspect of that's why I keep calling the TruPoint 300 a total station, because we have that extreme accuracy as a total station does.
Yeah, and that's how we market it. Agreed. I'm just the total station as people would typically envision one. You know what I mean? I was just wondering
Sure.
the setup and all that. Just the time again. So time again becomes an issue. I mean,
And you're by yourself too. When you're
yeah,
doing this stuff, a lot of us did it in my career. You don't have manpower, and even today's aspect of what's going on in today's world events. I mean, one of the first things that I noticed years ago was when things start happening with manpower. One of the first things they cut is training, then followed by traffic. They start cutting those two things down. And not to say, I'm looking at from the police aspect talking about this, is also the private sector. If you have somebody that you're doing this and you're a consultant, or if you're a retired police officer, you're doing a lot of the stuff by yourself. You're not out there with two or three people like we have the luxury over the years of doing a fatal crash scene. So it's a small, simple setup. It's a small case. It's one person carries it. Everything fits into one case. It's not like you have to carry around a support system around with it. So and I keep calling it a toll station because of its accuracy without plus
yeah,
minus 1 millimeter accuracy. We never had that before with the LTI equipment, and this is phenomenal for using for this. And
yeah.
one thing to say that you want to use to do a crash scene, you can do a crash scene. You got a small crash scene you want to measure with it because you guys designed it for small crime scenes.
That's true. Yep, yep,
Um,
yep. Okay. I was just
thanks for clarifying that, Vinny.
okay.
Now, this is a couple of screenshots of the QuickMap 3D. For those of you that aren't familiar with LTI's data collection software, it's called QuickMap 3D. You can do 3D measurements or 2D measurements with it. And it's very easily, it's adaptable to all the devices they make out there. And back again, we're back to wireless. This is a wireless transmission between the laser and the encoder, angle encoder, and the data collector. And you can fire the laser from the tablet. You don't even have to push any buttons on that. So you can walk around with this if you're doing two people, like for when we do crash scenes with the equipment that's now presently on the market. The person doing the angle laser, the angle encoder laser, can be angling at it, and the person firing the laser could be. We've been up to 120 feet away and fired the laser without a problem using Bluetooth on it, and it makes the system a lot easier. And we always joke when we do a lot of the training that the junior guy can then work the laser while the senior guy is sitting inside the car when it's cold or raining out, firing the laser from inside the car. So. But this is a quick screenshot how you're going to set up a file. You're going to select new survey. You're going to name the file. Then you make sure, because this QuickMap 3D works with all the laser technology equipment, you're going to select the TruPoint 300 on the device setting. Radial angle is a measurement. You want to default to feet because we're in the US. For you guys that are in Canada and so forth, you can do the metric system. It's in there. And then there's a little box down at the bottom that says 3D. You want to uncheck that box. It defaults to being checked, but you want to uncheck it because you want to make sure that you're doing your mapping in 2D. Because now once you're in 2D, you don't have to worry about measuring your target height. You don't have to worry about measuring your station height. You just start shooting because the way the system is designed, it flattens everything out to a 2D measurements, and it makes the precision measurements that way. Then you would tap next, and it takes you to the next screen, which is the next slide. Then you're gonna hit the transmit, the connect button, the laser connect button on the screen, and now it's gonna prompt you. These two screenshots are actually from the TruPoint 300 laser. It's gonna prompt you to electronically level the laser, so that way it matches up with your leveled tripod setup. And it's very simple. It takes like less than 30 seconds to level it. It takes you through a procedure. It's going to ask you to rotate it once, rotate it a second time, and then you're all set to go. You start shooting from there. Now, to set up your origin point, because it is a three-dimensional possibility for measuring, you have an X, Y, and Z axis. So everything's going to start. That's going to be the center of your universe. You need to do your measuring. Even though we're in 2D, it's still going to show the Z axis on there. And we're going to default, basically, if you know what your coordinate methods are, you can measure them in there. If you put the longitude, latitude, you can put it in. But if you basically we do mapping and measuring, you just default to the triple zeros, and then you fire. You're going to set up a reference point, and you're going to fire to that reference point, and it's going to establish your origin that way. Okay, next slide. So here's the way I set it up. You can see the if you can go back one slide, Vinny. I mean, click it back a couple clicks back. Okay, there we go. If you can see the bottom picture, you can see the tripod is set up to the left with the station on it, and then I used a prism pole with bipod legs to hold it because I'm by myself. So that's an optional setup you can get. And what's nice about it, it's perfectly plumb once you get that. It's locked into place. And on top of it, I have my non-reflector prism. You want to set this up about 25 to 30 feet away for purposes of doing this examination that I did for the webinar. I did a little bit closer. I did about 10 feet away because if I took a picture and it would just be too small, too far apart, the gap would be too wide right there. So as an example, for demonstration purposes, I show it set up this way. It's about 10 feet away. I measured it with a steel tape at 10 feet. And I also confirmed that measurements with the laser when I shot to it. So this way I know my accuracy is there when I do the measurements. And then you can see in the left-hand picture there, you can see the TruPoint 300 setup. Now, everybody confuses that little round part that's on that part that's sticking up. That's not a viewfinder. That's not this put your eye up to it, look into it, because the first time people set these up, they look into that. And I know when we do trade shows and so forth, people are coming up looking into it. That's your adjustment for angling for up and down height. You actually can turn a little knob to do precision turns, and there's a knob on the base to do left and right. So in addition to spinning it manually by hand and going up and down manually, you can do your fine tuning with two little knobs to do your fine tuning to get precision measurements in there. So I'm going to aim the laser at that reflectorless target, and you can see here, you can see right in the center, you see a little red dot, and that is the laser point they're going to be using. So that's a dot you're going to be seeing all over the place. Now, this was a bright sunny day. You can see, I can see that dot fine. So it worked out well, and a lot of concern sometimes, well, you can't see these laser pointer dots around and so forth. Well, this has a very high intensity dot that you can see really well during the day. And this set up my control point or my confidence point. And I want to make sure I mark that on the ground because I'm going to come back to that again before I'm all done, before I leave for the day. And you can see, again, how that car is tucked in with other cars. I didn't have to ask the tower, hey, can you yank that car out into the middle of the field, in the middle of your parking lot, me, so I can do my perimeter measurements and so forth. I did everything. The front was open. I did everything right from there. Next slide.
You know, one thing about that target at this point, you had indicated earlier, I just want to reiterate, you would not be using your typical glass, cut glass prism head for this unit. I mean, we had this specifically made for the TruPoint, this particular prism head, just so that everybody knows. I mean, we do sell those as well, but I mean, that is a non-reflective type product. And then we put the bullseye in there for a, you know, a point of reference for the user. But I just want to reiterate that it's not your normal cut glass prism
Right.
that we also sell. So just
Right. And these targets are much cheaper too when you come to that.
yeah, without a doubt. Yep.
Yeah, because we all know how much prisms cost. So now here's a screenshot of the Quick Map 3D collection screen, and you can see once I fired that to set my origin point up, it comes up as origin 1 is always the origin point. That's where your station is set up, the TruPoint 300 set up. And now when you after this point appears, you then want to fire at that point a second time because that control point they're using, or the confidence point as I call it, is an invisible point right now. It's not visible on your screen, so you want to make sure it's visible because you need that to be seen when you come back to this later on. So you're going to mark it on the ground. You also, and if you're going to traverse the station, you want to mark the station location, the TruPoint 300 location. You want to mark that with some spray paint, whatever you might want to mark with a nail or something like that, because if you don't want to use spray paint to damage a parking lot or so forth, even a washer on the ground works fine because you have the sole in the center where you're going to be aiming up to. And you use a plumb bob in this system. They just hang a plumb bob on the bottom of the prism tripod, and you can set up your point that way for your station. Next slide. So now you're going to shoot that as a point. So if you hit the point slot button one more time, Vinny, you're going to shoot that point as a that CP1 now becomes point number 2, so it becomes visible on your screen. And that's a nice thing about this the Quick Map 3D using the tablets as a data collector. You have a huge screen you can look at now. And if you look at that screenshot to the left, that's actually the screenshot when I was done. That was my last shot when I was done measuring everything. You can see how all the points, and I named the points. You can see how close together they are because the fact that, you know, they're on top of one another. You can't really detail what the words are on some of those points because they're so close together. But that's one of the great things about this tablet is the fact that you can see your points as you're shooting your scene. And as you go along, it adapts so it does the whole field. But you can zoom in. You can manually zoom in on any points if you want to make sure they're there. So you're going to shoot this CP1, the second, that's going to be point number 2. And you're going to come back to this. This is going to be your last point you're going to shoot when you're all done. And I'll talk about that in a few seconds. Here's a quick overview. Again, this is not a detailed course about the systems, but this is a quick overview of the Quick Map 3D field collection screen. Do you want to say something, Vinny? I thought you were.
No, I just wanted to point out that the camera, we had talked about this, yes. What a nice feature that is. So we highlighted it in this.
Well, there's a feature with this, as I mentioned earlier, you can take a picture with it. You push that little camera icon that's over to the right of the screen. It's got a red circle around it. You tap that and it takes you to the camera that's in the tablet. And then you can then take a picture, as many pictures you want to, and it assigns that point number to that photograph file number. So that way you know what it is. Like when we do the forensic mapping courses for LTI, like say, for example, you're shooting a phone pole as a piece of evidence or reference, and you know, I want to write down a pole number so I have it. Well, now this is your notepad. You can take a picture of the pole number. You don't have to worry about writing it down. It assigns it to that point number. So same thing here. You could use it for evidence. I know there's a lot of schools of thought back and forth about crash scene evidence photography, whether you should be using a digital SLR or if you can use a point and shoot. It depends upon what you're using, how you do it. Just remember, we're back into the police field that everything we do is discoverable. So if you're taking pictures, you can't just take them and then make them disappear. Everything is discoverable when you're doing this stuff.
And you know, these are good images that come from this too.
Yes.
I mean,
there's more pictures being taken with cell phones and tablets today than there are with cameras.
Yeah, that's right. And this one really does a great job. And we had talked too about the time it saves, just again, associating that image with that point, as opposed to having to take a note and who knows. I mean, you know, just
think of your typical crash scene. It's not during the day. It's not 70 degrees out. It's nighttime. It's raining. It's whatever it is. And we've all been there and done it. We use pencil and paper because pens don't work when it gets cold out, and it works if it's raining and so forth. Well, if you want to take a picture of evidence or references as you're doing your scene, you can take a picture of this. It's your notepad. It's your electronic notepad nowadays.
Yeah, no, really nice feature.
So now we're going to shoot our points. So you want to set up a systematic way you do it, whatever works for you. Clockwise, counterclockwise, left to right, right to left, whatever you want to do. But you want to do them in a sequence. So, for example, if I'm going to start at the front left corner of the vehicle in this situation here. I'm going to work my way down the vehicle, and I may set the points. I may do the corner, I'll do the axle, but then when I start getting to the damage area, I want to start at the beginning where the damage area is, and I may want to do closer measurements. You can measure as close as you want to, as far as away as you want to. You're the one that's doing the measuring. You can set up, of course, the more you do, the more detailed that damage profile is going to be when you go along with it. And now doing a single station, if I want to do the back corners or the other side of the vehicle, I'd have to use some sort of a pole, such as a prism pole with a non-reflector target on it. So I'm going to follow along the time. This is at the contact damage. If you hit the button one more time, Vinny, you can see the red dot right there. I went along the top of the tape because I could see the dot better going along the top of the tape rather than on the tape, because that silver bumper was more reflective, so I could see it easier. But again, this is during the day. This is bright sunlight out there, and you could see the dot without a problem at all. If in the event you can't see the dot, and I utilize this feature a couple of times that day, I tried to take some pictures of it, but it didn't work out too well because of the glare on the screen. And Vinny might be able to explain more detail how this actually works. But inside the TruPoint 300, there's a camera viewfinder that you can then, has crosshairs that you could use that screen as the aiming point, so you can look at it as if you're looking through a scope.
Is that, Rich, is that how you ended up doing that on the glare?
Well, the glare I was talking about, I tried to take a picture of the screen with my camera.
Oh.
And it was glare on the screen because of the sun. It didn't come out too well. But no, I utilized it a couple of times just to get the general area when I was going along. And then I turned off the camera and used the dot. It worked out because it was kind of hard to find the dot during the day, just moving it around. Like when I first started out, where my aiming points, I put the camera on inside the TruPoint 300, it's the view screen. And you could zoom in. You can zoom in so you can actually see where you're pointing. And it's got little crosshairs, or I don't know exactly what you call the crosshairs.
And then you could get that image. You can actually retrieve that image from the unit.
Yes.
Yes, that's what we were getting at. Yep.
Yeah. So I utilize both the digital view, if you want to call it that, but my main measuring, as I did it using the red dot and going along that way. So now I want to get those back corners because I can't see them, but I want to mark out some different parts of the car. I want to get the whole car. So again, here I set my prism pole up with the non-reflector target. And I keep emphasizing that because I don't want anybody to burn their lasers out. And I shot the corners of the vehicle. So this way I can get a complete profile. I don't care about, there's no damage in the back corners. I just want to know where it is. So that way I can get the whole vehicle. So when I bring this into my CAD program, I can get the precision overlay of the whole vehicle on it. I think there's one more picture on this.
No, just that showing the image.
Again, this is during the day, so you can see that dot without a problem. So now I would continue it all along when I was going around the vehicle. Next slide, if you want to go to the next slide. I did just set up at the back corner. You can see how I have the pole resting up against the bumper, and again use the bipod legs because this way it was set up nice and easy. I also did keep clicking, Vinny. I also did the axles, so that's why I could line up the axle points when I did my profile inside the CAD program. So as I go along those undamaged sides of the vehicle, I did the 2 axles on each side, and I did the back corners, and that was my measurements for a whole profile of the vehicle. And you would use that also to place the vehicle in the CAD program too, when you pull a stock photo out or a stock. Yes, because I want to line up. I want to make sure that not just the front of the vehicle that I'm going to compare to damage. I want to make sure the whole vehicle fits to scale, that it is proper scale. Okay. All right. Let's see. Again, here's my screenshot. The one on the left is the full scene, and you can see it has a point number next to each point, and then I gave a description to each one. Now, if I chose not to do a description, because I can do that, I can just leave that blank in the Quick Map 3D. I would just see points with numbers, and that would be much easier to see. But this. Now on the right is a zoom where I zoomed in on the tablet so I could see the profile right there. Vinny's moving the cursor along. Boy, look at you can see how close together the points are. You can't read what they are because they're on top of each other, but you can see the points as they go along. You can actually see the damage profile as you're measuring. And again, that's another nice thing about this data collector using the tablet with the Quick Map 3D, not just for the TruPoint 300 with all the LTI equipment. When you're shooting a crash scene, you get that anomaly point that it's out in left field. You can see that right away. So if you made a mistake on a point, you can reshoot it without a problem. And I tell you what, I cannot believe how many people call in
and talk about the screen, the ability now to zoom in just like you would on your phone. I mean, they absolutely love this about using that tablet.
Yeah, to zoom in, all I do is I do that pinch or sweep, whatever they call it,
Right.
that technique on the. I just touch
Yep.
the screen because it's a touch screen on the tablet, and I just can zoom in on. I can zoom in on one point if I want to.
Yep.
Okay, next slide. So now, speaking at one point, this is my last point I'm going to show. So now I took and I set my prism pole back up where CP wanted again. I left the washer on the ground, so I know exactly where to put the prism pole in the middle. So it's somewhat precision there. And I'm going to shoot this again as my last point. This is besides doing the fact that it's referring back to that pointer on top of another. This ensures I didn't kick the tripod, nobody moved anything, the angle encoder, the laser assist head didn't rotate around without getting a measurement. This is going to show me that all the measurements were done before and end in between point 2 and point whatever 45, whatever this was, my last point. It's on top of one another, and you can look at this right at the scene. So now, if, for example, if I take and I wind this up, and now I shoot that last point 45 and ends up being 3 feet to the left, something's wrong. I either have to go back and reshoot the whole thing or go back and look and see where my problem came in and start reshooting from there. I can save the scene. I don't have to go back and do the whole scene all over again if I look where the problem is. One of the things I recommend when I teach my forensic mapping classes, if it's going to be a big scene, you're going to shoot a couple of hundred points, maybe every once in a while, go back to that control point and shoot it. Because we all know when we're at a crash scene, we're measuring stuff, we get to talking to people, somebody walks around, you rotate, you kick the leg of the tripod, and nobody wants to say anything they messed up or did something, where the angle encoder starts to rotate on top of the tripod because you forgot to unlock the rotation lock on it, and you don't realize that. Well, if you're watching your points when you're measuring, you catch it then. But at the very end, you're going to confirm it. And this confirms everybody that these points are on top of one another, so nothing's changed in between. Now, now I want to decide to measure more than just one side of the vehicle. Well, now I need more clear space around the vehicle because I have to set the station up, the 2.300 total station up on those other sides of the vehicles. So if I need that clear space all the way around the vehicle. So you saw with the vehicle I used for the webinar, I couldn't get access to that other side of the vehicle. So I was able to just do it on one side. If I wanted to, I'd have to pull it out. So I need that 6 feet space all the way around to traverse the station. So I'm going to shoot to that new location. This is just a quick procedure how to do it. I'm going to shoot that point where I want to go to. I'm going to use a prism pole or shoot to the ground where I'll mark that spot on the ground, and I'm going to move the TruPoint 300 there.
And one of the things that we were talking about the other day, I mean, when you do traverse, now in the program, I mean, Cassie, who designed this, I mean, the traverse is so easy now.
When I teach my classes, I go back to when we first started all this out. We were all afraid to move the station because we didn't know what was involved in it and how difficult. It's so easy nowadays. And when I teach guys where they're upgrading their equipment, I've had a lot of guys say, "Man, this is so much easier. I never knew it was this easy." And you shoot to the point, and it takes you through a couple of steps in a program, and you shoot back to the point, and you're ready to go, basically. And you can traverse the station in less than 2 or 3 minutes. You're done.
Yeah, she did a great job with that, the whole thing. But that particular design for the traverse is really nice.
And then you're just going to follow through. It's going to prompt you to move to the screen. It's going to move to the station. You're going to hit next, and you're going to go back and point at. You're going to shoot point at the where you were with the previous station, and you're going to do this each time you're going to move along. So that origin is going to move as it goes along. So, okay, next. And this is a kind of a quick overview. Like if I'm going to do all 4 sides, I started at 1, I go to 2, shoot the back of the vehicle, go to 3, shoot that side of the vehicle, 4, shoot the front of the vehicle. The one thing that I want to make sure I emphasize or note here is that when you do traverse, sometimes you're prompted to re-level the station electronically. If you're prompted to do that, you just do it, and then once it's level, it takes you back to the screen of the 2.300, and you keep continuing on. It's not a problem.
And that doesn't even happen that often, really.
No, because if you level the tripod, you start out with everything level, it just detects that it's still level, so it's not a problem.
Correct, yeah.
And this is a quick couple of shots of the screens that take you through it step by step. It's 4 steps. on the screens and you're done. Now I'm going to take and put this into my CAD program. I'm all done with the scene. I've packed everything up. One of the nice things about the way the system's set up is I emailed the files to myself. I downloaded it into my CAD program. Once I get back into the station, I'll put my emails up and I can do it. I draw the damage profile in the vehicle on its own layer, and then I superimpose that over a scale diagram, either at my library or I made another scale diagram of an exemplary vehicle, or I obtained one someplace off the internet or so forth. And then I use the CAD program to take my crush measurements.
You know, the emailing is nice. We had talked about this as well, that it's a really nice feature. Every so often with the firewall in a police station, it may, you know, you may have to actually set up like a Gmail account that you might have or something like that. But other than that, I mean, that doesn't happen all the time. But again, like you said, it does happen every so often. So, but again, not that often. So,
okay, next slide.
Okay.
So here's just a kind of, this isn't out of a CAD program. This is just a quick diagram made up when I did an instruction sheet. You have your damage profile, you overlay over top of the exemplary vehicle or the exact vehicle, and you do your measurements by where those blue arrows are. You measure with that with your CAD program where the vehicle's undamaged side is compared with the damages. The next slide. So here's a screenshot of the CAD program showing all my points. You can see the oval to the right is my damage points. That's where I did them closer together, so I had more precision measurement. And then you can see that all the way to the left, you see that dot in the back. That's the corner of the vehicle, and then the one to the right of that is the axle. So I did that all the way around the back of the vehicle so I can line it up when I do my measurements in the CAD program. Next slide. So now I connect the dots to my drawing, and there's my profile of the damaged vehicle. And that took me probably a total of maybe a couple of minutes to do all that, really. It didn't take that long. And if you wanted to, you can have the CAD program draw it yourself. You can also use in QuickMap 3D, you can do features where it'll draw these lines for you as you're doing it too. So
Yeah.
you can do it that way too. You don't have it automatically drawn. Okay. And a little bit closer up, you can see the detail on it. So next slide. Now I overlay my red outline is the actual measurements of the Volvo. There was not a Volvo station wagon of this age in the library, so I had to achieve one off the internet, and I got an actual profile of one there. So I overlaid it over top of it. You can see my corners line up. You can see my axles line up, and now I can zoom in.
Oh yeah.
On the next slide.
Okay. Yep.
Now I turned the dots off, that layer of dots, and now I have my damage profile and I have my undamaged profile. So that little void is where I'm going to take my measurements from. So now, depending upon how you do this, your schools of thought, some just measure the depth where the contact damage is. Some measure the whole damage point. So next slide. Yeah, I worked with different layers, so you can see I can turn them on and off, so I can make my ease of measuring and looking at things. So everything's on a different layer when you do that. Next slide. Now I took and I measured my contact damage width was 10 inches, and I measured that in the CAD program. I didn't have to measure. I measured at the scene just as comparison, but I didn't have to if I didn't want to. And now, depending upon how many C measurements I want to take, I'm going to divide that up by that number. So I set up here, so I have 6 C measurements, so I divided it by 5, so I get 2 inches for each one. I measured those 2 inches in the CAD program, marked it, and then I measured my depth from, you can see from the red line to the right, which is my undamaged profile, into the contact damage. You can see my 6 C measurements. It starts at the bottom. C1 will be 12 inches, 14 inches. And again, with your CAD program, you can measure this in inches, metric system, how many decimal places you want to go out. I chose 2 decimal places, and I did all my measuring in the CAD program. Next slide. So you can see now here, I turned off a couple of layers. I have my contact damage width. I have my C measurements 1 through 6, and I can then enter that into my program to do my crush measurement.
And that's going with the 6. You had said you could do 8, 10.
It depends upon what you want to do, how detailed you want to be, what your program. I think the minimum is 4, and you can go up to 10, 12, but 6 is kind of the average that I've heard a lot of guys do it with.
Okay.
And then the next slide shows, well, I decide I don't want to do the whole width of the damage area. I'm going to measure the whole thing. So now it's 34.4 inches. I divide that into 5 equal parts. That's 6.7 inches. And now I do my measurements off of that. Now I come up with my C1 and C6 are going to be 0 because it's going to be right at the beginning. And I have my measurements in between of 5.7, 11.6. And again, my deepest penetration is 16 inches.
Huh.
And there's an alternate method. If I can't find an exemplary vehicle, this is kind of the old school way. If you're doing it by hand, you lay something up against the undamaged sides of the vehicle, measure in from that. I could draw a straight line from undamaged side to undamaged side, and then measure my crush measurement inside. So that's another alternate method to do it like that. Okay. I see there's some questions on the screen too, so we have some time.
Yeah, there are, and I had a few come in too. I'm going to read mine, and then I think Jay is going to pop in and answer some or ask some that have come in. So one of the ones that we had was, okay, it says, Rich, when is crush performed? Is it performed with every accident? Is it a dollar amount at which it should be done? What triggers the need for the crush measurement as part of your file for that accident?
Well, it depends upon what area you're looking at. If you're looking at it from the crime police end of it, or if you're looking at it from the private sector. I know and there's a lot of guys that don't believe in crush. They don't like it because they don't trust the analysis on it, that, because of the stiffness coefficients, frictions of the vehicle. The vehicle's old, new, it's been damaged before. There's all different schools of thought as far as the accuracy of it. But in today's day and age, you run into this a lot in trials. Like, well, why didn't you do this? If you knew about this technique, why didn't you try to come up with it? It's just another tool in our toolbox to come up with our calculations, just like the event data recorders for airbag control modules. It's another tool. Drones, it's another tool. You can't rely on just one thing nowadays to do all your work from. You want to be able to confirm your calculations, your analysis of a crash any way you can. So now here's a simple way to do crush measurements, because before it wasn't simple. So a lot of us didn't do it because it wasn't simple. It was time consuming, and we didn't rely on the accuracy of it, and we didn't have the programs to do the calculations. So if you want to do the calculations longhand, you're there for a long time doing it by longhand too.
Okay. I didn't know if something prompted it, like a dollar amount or like.
I would look at it this way. Now, if this was 10, 15 years ago, and when this was out, I would do a damage profile for every vehicle. And you got to remember too, these damage profiles aren't just for crush. In the beginning, I talked about the fact that you could use them for putting the vehicles together, maximum engagement. So it's more than just a crush measurement. It's a precision damage profile of the vehicle that you can use for multiple different aspects of it.
Okay. Let's see, Jay, do you have any? I have another one too, but Jay, do you have any that came in?
Oh, I do. I have a number of really good questions.
This was great. Great stuff.
Let's start with, well, you're talking about doing this in 2D, Rich. Is the problem doing it in 3D if you're shooting a scene in a vehicle?
Nope, you can do it. You can do it in 3D if you want to. You can do a detailed 3D analysis of the vehicle if you want to, and draw it in 3D. This was just a quick down and dirty aspect of doing a flat 2D diagram with the outline of the vehicle, not detailed as far as the whole vehicle, but there's nothing to stop you doing it in 3D. It's going to take you a little bit longer because now you have to make sure you're going to have to measure the target height. You're going to have to measure the prism height. You have to adjust that because there's a process. And when you look at the use of the Quick Map 3D, you can do an indoor crime scene. You can measure the height of the ceiling, the height of chairs, everything. It does it, and it's not as quick and easy as 2D, but it's not very difficult to do. You can do it in 3D if you want to.
That's great. Another question as far as a prism placement. If you work in an area where there's high winds, would there be a problem putting the prism closer to the ground on a shorter tripod?
No,
but you can actually shoot to the ground with it if you want to. Like one way of moving it, like I talk about moving traversing the station, is you shoot the point on the ground where you want to move it to, mark that point and move it to it. You don't need to use a prism pole. If you can see the point, you can shoot to it. Put it that way.
Okay, that's awesome.
So you don't need to put a prism pole on the ground. You can shoot to the ground. It'll reflect off the ground.
That's great to know. Vinny, did you have additional
Yeah, I
questions? I
did.
still
So
have some
I
more
think,
here.
yeah, Rich, you kind of answered this. Somebody wrote in and said, when calculating speed from crush analysis, how many C points do you use? Um, you know, they were wondering if it could be 6, 8, 10, or more, or but I think you answered it by indicating that 6 is kind of the average, or
Yeah,
it's
6 is, yeah, again, it's detail, how precision you want to be. The more you do, the more detailed the answer is going to be. The more the and you could justify your fact that you're going more measurements to be more detailed, more precise. Is what you come up with on it.
let's see. The other one kind of goes with this last little slide of contact, and it just said, is there a way to get one of these units or one of those kits as a demo unit? And yes, there is. You can get in touch with your regional salesperson or get a hold of LTI through any of these contact methods. And it is questions regarding, not regrading. I don't think we're going to regrade QuickMap 3D. We already know it's wonderful. But if you'd like to try one of these on a demo, we do have a demo program that you can bring this into your department, or if you're not with the department, if you're a private type person doing this, that you can try it for a few weeks and see how it works for you, both in a small crash site or doing crush like we talked about today, or even a small crime scene, or even fire. I mean, I don't know how many out there might be fire people today, but this the TruPoint 300 will also work in a fire environment because of the visual laser. So the visible laser. So that was just in case that person would like a demo. You can contact us one of the ways up here.
There's a couple of questions I see here, Vinny. I don't know if they're showing up on your screen or not.
No, let me.
Yeah, I have
One of
quite a
them,
few.
somebody asked if you can use a TruePulse 200X and TrueAngle to do this. Yes, you can, but you don't have that plus or minus 1 millimeter accuracy.
Right, 6 inches.
I mean, you can do it, and we've done it before, but you have a plus or minus 6 inches accuracy with that, so your accuracy's off a little bit. And you could do it if you want to, but your precision's gone.
Hey, Rich,
Yes.
to follow on with that, can you do crush analysis with a drone?
I wouldn't rely on it. You could, but the problem with the drone is how you're going to see into the depth if you're shooting it from overhead. Then you got to fly it low, and then you got the whole drone issue is where you can fly the drone. Because one thing that I've noticed with police, they tend to, when you get into drones, they don't follow a lot of times what you're supposed to. You need waivers to fly over people, fly over roads. There's a lot of issues with drones right now with the regulations of where you can and can't use it. But you'd have to get down, and because if you're shooting it from overhead, as your example you saw, my overhead shot showed the hood.
Yeah.
But the actual deepest intrusion was way below that, where the bumper was in. So if you're just doing an overhead picture, you'd have to get side pictures and so forth, and then you're going to use a Pix 4D or something like that to do your measurements. And the guys that use that are finding out that some of their computers can't handle that. You have to go to the cloud for storage. This is a very simple, down and dirty way to do it when it comes down to it.
I know that it is at 11 o'clock now. Yeah, it is 11 o'clock, so
Yeah.
we've spent our hour, but I have a number of really good questions. Do you mind staying a little longer just to do the question
I have
and
no
answers?
problem. If they want to stay on and listen, I have no problem.
Okay. Thank you, Rich. We also have a question on what CAD programs can use the data from the TruPoint 300. Maybe Vinny or Cassie can answer to that.
Yeah, Cassie, are you on in an unmuted position where you can tell them? I know ARS 360 and Faro, like we sell, Survey.
Well, one of the nice things about the QuickMap 3D is it saves the file in like 6 or 7 different formats.
Yeah.
So it'll work in any CAD program. Any CAD program with a DXF file, it'll take. That's your basic CAD program.
And does QuickMap 3D work on only Android, or does it work on iOS as well?
Works on both. One of the things that when we do the forensic mapping, and Kevin Fremont, who I work close with, can attest to this, is that we recommend and we kind of work with our customers and say, put it on your phone too, because if something happens to your tablet at the crash scene and at 2 o'clock in the morning, you can always use your phone, whether it be an Android phone or whether it be a what do you call it, an iPad phone or a
iPhone. Yep.
you can use it on that because it's Bluetooth connected. The connection between the TruPoint 300 and the tablet is not Bluetooth. It's what's a WLAN it's called, I believe. It's
WLAN.
WLAN, but it still connects wirelessly, so it's no problem. Both of them can be utilized.
Vinny, this might be a question that you can handle. Someone says that they were using the TruPoint 300 outdoors in 70-degree weather, but it was direct sun, and they were having trouble with the instrument overheating. What would you suggest?
That was an issue at first. Cassie's on here too. They made some changes to alleviate that. Cassie, could you just tell them what was done to try to alleviate that? She with us still?
She has to be unmuted, I think.
Oh, let me see. Can we unmute her? Let's see.
Oh, am I unmuted now? Sorry, I've been talking to myself like 4 times already.
Cass,
okay.
Yeah, that's fine. Hey, Cass, didn't you do something with that to try to mitigate?
Yes. So we did a firmware upgrade for that, for the way that the screen was dealing with it. And it helps. So you should check the firmware version if you have a TruPoint 300 already. If it's 3490, it needs to be updated. And we have a firmware updater program on the website that you can download for free. It's a few steps. You just plug the laser into your computer with the cable that you use to charge it, and then perform the steps on the screen. It's not that difficult. So once you have that, you shouldn't have too much of a problem with it unless it's extreme, like we're talking 100 degrees or something. You should be okay. You need an umbrella from that point.
Yeah. Okay.
Rich, I have another question. They were wondering what function you were using on the TruPoint 300 in order to get the measurements. I'm
not sure what he means by that. I set it up like we normally do from mapping scenes. There was no function. It's all pretty much self setting up as far as the mode it goes into when you hook it up. Okay. Kathy might be able to answer that better too.
Yeah, I don't know what that even question.
Yeah, I wasn't sure either, so I was hoping some of our experts would know more.
Okay.
Right. So when you pair a TruPoint 300 to QuickMap, it's automatically in the mode that you need for mapping. It recognizes that.
Yeah, I think maybe he's talking about because if you use a QuickMap 3 by itself, you can do all kinds of stuff with it, which you need a phone book to read to understand a lot of it.
Rich. Okay.
Cassie, this is definitely a question that you could probably field. Someone was wondering if the QuickMap 3D app could be paired with other total stations.
No, at this point, the only equipment that works with QuickMap 3D on Android and iOS is our Bluetooth enabled models of our own LaserTech lasers. So TruPulse 200X, TruSpeed SXB, and TruPoint 300.
I know that question's come up a lot of different, when Cassie and I have talked about that, it's come up at a lot of different trade shows we've been at.
Vinny?
Yes?
Here is the all-important question. How much does this cost, and does it come with training?
Well, the kit itself is extreme. I mean, we know that total stations are tens of thousands of dollars. This unit is right at $3,000. It's even less now. We have it less than $3,000. Training depends on how much training they would need. If it's just a day, it's going to be X. I mean, we have all those schedules in our price book, and we could go over those with the agency involved or the person involved, whether they need a day, 2 days, that kind of thing. So, but that kit itself, as we showed at the very beginning, is under $3,000.
And is there an annual fee or a subscription fee for updates?
No, but we should. No, I'm just kidding.
Everybody else is. Why not?
No, Cassie is oh my goodness, she updates it often. I mean, not that it's bad, just to make improvements, and that just comes as part and parcel of the app. So.
And I think this is a question that Cassie can answer. Can GPS coordinates be incorporated into the maps made by QuickMap 3D?
Okay, that's a good question because I was just going to interject with the previous question about updates. We have a version that we are adding GPS to. So you can set up the origin with GPS, and then every point you shoot from there, including traverse points, are calculated offset coordinates, like a remote target. So every GPS point or every laser shot has a GPS long lat associated with it. And then the new output format that goes with that is called GPX, which can be uploaded into ArcGIS Online, if anybody's ever heard of Esri, or Google Earth, and you can look at the points relative to the terrain, the planet.
Is that available now?
So, and then it is not available yet. We are working on it. It's actually done being tested. I'm just doing the documentation for it at this point, and it'll release probably within the next 2 or 3 months.
That is awesome to hear. Thank you, Cassie.
It's a free update as well. It doesn't cost anything. So you'll just get a notification. If you already have QuickMap, you'll just get a notification that there's an update, and you just accept it, and it'll be there.
What is the maximum effective range of the TruPulse 300 or TruPoint 300? Is it affected by conditions? What would the parameters be for that?
Oh my! As far as
Cassie might know the technical aspect of it.
Yeah.
I can't remember what it is, to be truthful.
What is it,
Okay,
Cassie?
so the range is 1,000 feet for the TruPoint 300, but for the application that we're discussing today, I don't like using it at farther than 200 feet, just because it's a through the scope. It doesn't have through the scope magnification like a TruPulse 200X. That's more designed for that, for farther away shots. Like if you want to stand in one position and get an entire scene in, you can usually do that with the 200X. With the TruPoint 300, it might take a few more traverses because you just want to be able to see the accident, and it doesn't have any magnification. So it has a little bit on the camera. I take that back. I think it goes to 3 times on the camera, but it's still more difficult than looking through a scope. So right. I like to keep it within 200 feet.
There's a question I saw on here. Somebody asked, Joe Catone asked about, how did I mount the prism to the prism pole? There's an adapter that goes between, because that was one of the things that I discussed with Vinny, that there's different sizes in that prism pole thread mounting, but there's an adapter that goes in between there to mount that on there. And then he also asked about using a laser level. This thing just jumped down on me for some reason. Where did it go?
What was that?
He asked, can use a laser level be used to create the level plane for the measuring brush? Does that interfere with the TruPulse 300? TruPoint 300? I don't think the laser would. You could. I know what he's talking about, those laser levels that make the red line go across.
Okay.
Cassie, do you know if another laser reflected off of that surface would interfere? Because they're tuned to different frequencies, right?
Right. No, it wouldn't interfere if you use a different tool.
Oh, I see what
but
you
the TruPoint 300 itself does have an electronic level on it. If they ever needed to use that before they start their measurements, you can find level with the TruPoint 300 as well.
I think what he's talking about is, those levels you can buy at like Home Depot to put a red line on your wall where you're going to mount something.
Right.
That's the type of level I think he was talking about, to make the red line on the side of the car to do it that.
Vinny, going back to the kit cost.
Yeah,
what's included?
Is this for Joe Morrissey?
Yes.
Yeah. So no, Joe. I just wanted to let you know that the Faro 2D that Rich has talked about throughout would add $400 to that price. So that does not come with the kit, but the QuickMap does, the tablet does, everything else, the tripod.
And you can also mention, I'm not a sales guy, but one of the things that you already have a setup, you don't need to get a new tablet. You can use your existing tablet with this too.
Yeah. But as far as Faro, for a CAD program, if they don't have one, the Faro 2D
is cheap for $400.
Yeah, $400 it would add to that, Joe. Okay. Let's see what else.
Somebody just typed in that they got an older unit.
Yeah, that was Joe. Yeah,
okay.
That's the same gentleman.
Wonderful. I believe that that covers most of the questions.
I'm looking.
If anyone else has a question that they need to know, now's the time to type it in.
Or they could always send it to us, and we'll get
That's
with
true.
Rich or Cassie or myself, and we'll be glad to. I did want to say this has been recorded and will go to everybody that was on there. Everybody that had registered or was actually live on this, we will be sending the recording. I don't want to speak out of turn, Jay, but we'll be sending the recording, correct? And then
Yes, that is true.
also some videos that we have that we took on both the TruPoint in action, a video we put together, and also the other setup for actual crash mapping, say with the TruPoint 200, the 200X and the True Angle, that kind of thing will be coming your way as well, just so that they're aware of that.
Yes, you took the words right out of my mouth,
Oh, okay,
Vinny.
I'm sorry.
I wanted to remind everyone we are recording, and that means that the questions and answers will also be recorded into the webinar recording. And as soon as that recording is rendered and we have it posted publicly, we will send out a link for everyone.
Okay. If that's it, or is that it, or any more? I mean, this was Rich. I want to thank you so much for doing this. This was wonderful. A lot of great information. And again, the one thing I do want to stress: if anybody, what have I done? If anybody does want to try this as a demo, we'd be glad to send out that TruPoint 300 kit for them to try, crush, or whatever they'd like to, a small scene or put together a mock scene, whatever. So just feel free to contact us at any of these ways on this screen and be glad to help.
Well, thank you everyone for joining us today. We've really appreciated the conversation that we have had. And Rich, thank you so much for joining us and giving us this information.
Anytime, Jack.
Yes. All right. Well, everybody, I guess have a good rest of your day. Yes.
Stay safe out there.
All right.
Yes.
Thanks again.
Thanks a lot, guys.
All right. Bye.
Bye.